In this video, we will be studying arithmetic sequences and series. Now, arithmetic sequences are just patterns of numbers that increase or decrease by the same number, which is called the common difference. So here, we will have now an example of an arithmetic sequence. Let's start, for example, with 5, 9, then we have 13, 17, and so on. So as we see here, the numbers or the terms increase by 4 every time. So here we have plus 4 every time. And this 4 is called the common difference. So here we can say that the common difference D is equal to 4 since it increases by 4. These dots means that this sequence continues like this forever, and it's called an infinite arithmetic sequence. Another example here, let's say we have, for example, 50, then 44, and 38, 32, and so on. Here, as we see, the numbers decrease instead of increasing. So here, they decrease by 6 every time. So that's why here, the common difference would be negative 6. Here, D is negative 6. So as we see, when D is positive, the sequence increases. But when it's negative, then the sequence decreases. Another example here where you have a finite arithmetic sequence here. For example, now let's say we have 6, 12, 18, and so on, but here up to, let's say, for example, 54. As we see, this sequence here just ends at 54. It doesn't continue forever after 54. So this is a finite arithmetic sequence, whether these here are infinite. Now, each number of these is called a term in the arithmetic sequence. So for example, here 5 is the first term, and 9 is the second term, and so on. A common idea we use for the common difference or to know the common difference is this. The common difference D is any term in the sequence minus the previous term. So, for example, the common difference D would be, let's say, the second term minus the first, or the third term minus the second, or even like, let's say, the fifth term minus the fourth, and so on. This idea here is very common in exam questions. So, for example, here, if we need to find D, it will be 44 minus 50, which is negative 6. Here, 32 minus 38 is also negative 6. Here, for example, 17 minus 13 will be the common difference 4, and so on. Now, we will focus on this sequence here, and we will solve some common questions that we might encounter in sequences. So here, for example, let's have a question like this. Find U50. It means we need to find the 50th term in this sequence here. So, of course, we shouldn't continue and write here 50 numbers manually till we reach the 50th number. Instead, we use this formula here, which is the nth term formula of an arithmetic sequence, to find or jump to any single term in the sequence. So if you apply this formula here, we will have U50 would be, here first we have U1, which is the first term. In our question it's 5. So here we have 5 plus, here we have n minus 1. N is the position of the term. Since we need the 50th term, then n will be 50. So now we have here 50 minus 1, then multiplied by the common difference D, which is, in our example, 4. And if we calculate these, it will be here 201, which means if we continue these numbers here, then the 50th would be 201. Now, another question we might encounter in sequences is arithmetic series, or the sum of n terms of an arithmetic sequence. So here we have a sequence, but when we add all the numbers one by one, like 5 plus 9 plus 13 plus 17 and so on, we would get what we call arithmetic series. And of course, we don't add the numbers one by one. We have the formula here to get the addition or the sum. Here we have two formulas that give the same result, but the difference here is this. Mainly we use this formula where we have or need the common difference, but if we know the last term, which is this, we can use this formula here. This would be easier if you know the last term here, and here you don't need the common difference, as we see here Sn and Un. So Un represents the last term as we see in our example. So here a question that we might have like this: find S50, which means find the sum of the first 50 numbers of this arithmetic sequence. Like if we add 50 numbers here, what is the answer? Like 5 plus 9 plus 13 and so on up to 50 numbers, what is the answer? So here we will apply both formulas because we can and we know the last term. We'll explain here first this. So here S50 would be, here we have n divided by 2, which is 50 divided by 2 because n is 50. Here we have 2 multiplied by the first term, so the first term in our question is 5, plus here we have n minus 1 times the common difference, so n minus 1 times the common difference 4, which is now, if we calculate this in our calculator, we would get 5,150. But now we can use here this second formula because we know the last term. So here, the last term, you shouldn't think that it will be the term like that's very, very far from this. No. Here, since we're adding only 50 terms, then the last term will be the 50th term, which is here found in the previous question, 201. This is the last term in our series, 201. So if we apply this formula here, we will have S50 will be, here we have also n over 2, so we have 50 divided by 2, then here we have U1 plus Un. So U1, the first term, which is 5, plus Un, or the last term, the 50th term, which is 201. So plus 201. And if we do this, we will also get 5,150. Now, another question that we might have on this sequence here is this. For example, they might say, is 147 a term? So here, is this number here, 147, a term in this sequence? Like if we continue writing these numbers, will we have or encounter 147, or we will jump over it and have other numbers? So here we do the same formula here, the nth term, but in the opposite way. So now here, instead of Un, we know that now our term is 147. So we will say 147 equals now, here we have U1 plus n minus 1d. So U1, which is 5, plus, here we don't know the value of n, so we keep it as it is, n minus 1 times the common difference d, which is 4. So now we will solve here for n. If we get a whole number, let's say for example 40, it means 147 is in the sequence and it will be the 40th term. But if we have a fraction or decimal number, like not a whole number, it means 147 is not in the sequence. So here, to solve for this, I will move 5 first and subtract it. So 147 minus 5 will be 142 equals n minus 1 divided or times 4. Now we will divide here by 4 and here by 4. So here 142 divided by 4 will be 35.5 equals, here we have just n minus 1. So if we add 1, n will be 36.5. And now, since we have a decimal number, not a whole number, it means 147 is not a term in this sequence.